All right, guys, welcome to 4.5. This is our beginning of our graphing section. In this first unit, 4.5, we're going to be talking about graphing sine and cosine. There are 3 review questions. Go ahead and do those. I should just take you a moment, and then I'll be right back and we'll talk about them. Pause the video. Cosine at 0, that would be 1. Find angle B if cosecant B is 2.8876. Round your answer to the nearest degree. Over here to the right, sine at B, because that's the opposite of cosecant, would be 1 over 2.8876. So the inverse sine of 1 over 2.8876 is approximately 20 degrees. And then number 3, find the cosine or the cofunction to sine 34. That would be cosine 56. Today, we're going to begin graphing sine and cosine in an xy plane. The graphs of sine and cosine are periodic with oscillating patterns. We call these sinusoidal waves. Music is composed of waves of different frequencies and amplitudes, and these can be described using sine and cosine waves. In fact, most anything involving sound waves will rely on sine and cosine. GPS and cell phones rely on triangulation and formulas involving sine and cosine. Signal transmission, such as TV and radio broadcasting, also involve sine and cosine waves. So in our first example, we're going to graph 3 different graphs on this. So you can either get 3 different pens color-wise, or I don't know, try dash lines may work. Just kind of one of those things. You're going to put them all 3 on the same coordinate plane here. State the period and amplitude for each, and then state the domain and the range. So the first one we're going to talk about here is going to be y is equal to cosine x. Now, normally when you graph, you start by just taking an x, plugging it in, figuring out what the values are. But keep in mind, I don't want to go all the way around the unit circle using values that are going to be hard to use, like root 3 over 2. That's a difficult one to use. So we try to use values that are simple values to use, and that will help us just to graph these points pretty quickly. Also notice, our xy plane is a little different. Our y values are still going to be scaled by 1s, 2s, whatever. But our x values are now being scaled in radian measure. This just helps us to kind of figure out where we're going to be in these. So, first value that we could plug in here, well, 0. Cosine at 0 is 1. I go over to my graph. I'm going to say this is 1. I'm going to put my point right here. The next one that I know I can find, well, that would be pi over 2. At pi over 2, I know that cosine is 0. So at pi over 2, I'm going to come over here and I'm going to put in 0. The next one that I would know for sure, well, that would be pi. Cosine at pi is negative 1. So now I'm going to say this is negative 1, and I'm going to go over here and I'm going to put that point in right here. The next one that I would know that I can answer, 3 pi over 2. This one is going to give me a 0 again. So I go back to 0 on my graph. And then the last one is going to be 2 pi. Well, cosine at 2 pi, I'm right back where I started at 1, which puts me right here. So this thing looks something like this. It's going to be fairly flat. It's going to come down here. It's going to bounce off of this point. It's going to come back up here, bounce off that point, and it's going to continue on in both directions. Now, when you draw these, I'm going to want to see that you've drawn your picture complete, meaning I want to see it drawn through this whole picture. So you're going to have to come back on the other side here and understand that this one's going to be here, this one's going to be here, this one will be here, this will be here. For this one, though, I don't need you to do a solid line. You can just do a dash line to continue it on. So that one is cosine of x. Y is equal to cosine of x. It said that they wanted you to find a couple things. State the period. Well, period here is 2 pi. The amplitude is just 1 because we're only going from what we call the midline, which I'll put that in my picture. This is the midline right here. It's coming across here and it would be the midline. And it is y is equal to 0. And we call it the midline because there's no point that gets any farther away than 1 from the midline. So our amplitude here is 1 because amplitude measures how far from the midline to the furthest point up or down. And it's also never going to be negative when we say amplitude. The next part of this said to state the domain and range. Well, our domain, it goes on forever. Our range, well, the range is going to be everything from -1 to 1. That would be our range. So that's for just y equals cosine of x. The next one says that y is negative or equal to negative cosine x. We do the same thing. I first got to come up with an xy thing. It's all cosine, so I'm still going to start here with 0. But now because the -1 is out there, the negative is out there, this answer is going to be -1. So now I'm going to start down here. And then when I go to pi over 2, well, that's going to be 0. The negative won't affect it. So it's back to the center point right there at 0. Pi, that's going to be now +1. So -1. 3 pi over 2, that's going to give us 0 again. So we're back to 0. And then 2 pi, we're back to where we started, -1. And so now we should be able to see that this thing is just flipped in terms of that. It's going to keep going in that direction. And then just like before, we need to fill in the other parts of this picture. So it's going to do something like this. And now we have our picture. Kind of looks like a double helix. Now they're asking you for the same things here. What is the period, the amplitude, the domain, and the range? Well, the only thing that happened was we just flipped the picture over. There's the same for all of those. Those didn't change. Keep in mind as well that that value out in front, that was negative. That's like your a value in a normal function. And your a value reflects across the x-axis. That's exactly what happened here. Now this last one is saying y is equal to 2 cos x. So we're going to take our xy plane. Since it's still cosine, we're going to say 0. We're going to say pi over 2. We're going to say pi, 3 pi over 2, and 2 pi. Now when I plug in 0, I get 1. 1 times 2 is 2. When I put in pi over 2, I get 0. When I put in pi, I'm going to get -1 times 2 is -2. When I put in 3 pi over 2, I'm going to get 0 again. And when I put in 2 pi, I'm going to get 1 times 2 gives you a 2. So now when we look at this picture, we're going to have the following. 0, 2. Now I'm up here. It's still going to go through 0, so I've got all the points going through that same spot. But now it's going to come down to -2. It's going to go back to 0 and back to 2. So this thing is going to do something like this. And over here, same idea. It's got to go through here. It's got to go down to 2. It's got to come up. It's got to go to here. So this thing is going to be doing something like this. And it's going to continue onward. Arrows on both ends. That has to be the case. They want to know what is the period here. Well, our period is still the same, 2 pi. It takes 2 pi for this thing to go through one whole loop from 0 to 2 pi. Our amplitude, well, now our amplitude is different. It's now 2 because from the midline we have to go up or down 2. Our domain, well, that doesn't change. Still all real numbers. And our range, well, our range is going to be everything from -2 to 2. So hopefully we see what's going on there with that. Continuing on with our notes, it says the period is 2 pi for all periods here. So we're going to be using 2 pi. Uh-oh. Hold on one second. I think I pushed the wrong button. Yep. 2 pi for all three, because the period tells how many radians are needed to complete one pattern. And one pattern was just half of that thing. We just extended it on the other side. The amplitudes are going to be 1, 1, and 2, respectively, because the amplitude is the distance from the midline to the highest or lowest point. The domain for all three, well, the domains were all the same, negative infinity to infinity. The range for the first two was everything from -1 to 1, and for the second one, it was everything from -2 to 2. And if y is equal to a cosine x or a sine x, then the period is going to be 2 pi, and the amplitude is going to be the absolute value of whatever a is. Now, when I say whatever a is, that's just the number that's out front here. This is not a division. We're not dividing cosine by sine. They're just meaning it's either cosine or sine here. So hopefully that makes sense in terms of the graphing part of this first thing. That was for cosines. Now, we're going to be doing the same thing for sine. So let's take a look at it. I'm going to start with these first three. So sine is going to be, in this case, y is equal to sine x. Well, the period, we already said, 2 pi. The amplitude in this thing, 1. The range in this thing, because the amplitude is 1, and it's going through, in this case, our midline. Sorry, let me get a different color here. It's going through our midline, which is right here. So here's our midline. And that means that our range is then going to be everything going 1 up or 1 down. So -1 to 1. That's for sine. Let's go ahead and graph that one. So y is equal to sine x. We need an x and we need a y. Now, just like before, the best values we can use, 0, pi over 2, pi, 3 pi over 2, and 2 pi. These are just our basic ones till we start doing some other things. But for right now, these are the easiest ones for us to use. So when we put in 0, we're going to get 0. We put in pi over 2, sine at pi over 2 is 1. Sine at pi, 0 again. Sine at 3 pi over 2 is -1. Sine at 2 pi, 0. So I'm going to go to my picture. We're at 0, 0. So we start right there. We have pi over 2, we're going to be up 1. So I'm going to say that's 1. We have pi, we're going to have 0. 3 pi over 2, we're at -1. So I'll put a -1 in there. And 2 pi, we're back to 0. So unlike cosine, this one starts at 0, 0. And we're going to use that idea as we go further, because sine always starts at the 0, 0 of the midline. Sometimes the midline changes, but that's usually where it's always going to start. Going back the other way, just like we did, we got to go down to -1. We got to go back up to 0. I got to go up to 1, back down. So this one's going to be doing something like this. But remember, it's everything from here to here is considered one period, because that's how long it took us to rotate back to 2 pi. So this is 2 pi. Domains in these, well, they're always going to be all real numbers. Okay. Now let's take a look at this next one. For this next one, we're going to plot this thing first, and then we'll work on it. So y is equal to sine x plus 1. We have an x and a y situation. We have 0. We have pi over 2. We have pi. We have 3 pi over 2. And we have pi. So putting in 0 into this equation means that we're going to have sine at 0, which is 0, add 1, we get 1. Sine at pi over 2 is 1, plus 1 is 2. Sine at pi would be 0, we're going to add 1, we go back to 1. Sine at 3 pi over 2 is negative 1, that makes this 0. And then sine at pi, 2 pi, we're back to 0. No, we're back to 1 because we're going to add 1. So start with the first one, 0, 1. So now we're going through here. And then it's going to be pi over 2, we're up to 2. And then down to 1 again at pi. And then down to 0. And then back up to 1. Now, I said that this would go, it's going to be 0, 0 on the new midline. Well, what's happening here? If we look at this thing, it's saying plus 1, and everything got shifted up 1. Well, this is really our k value, plus 1, something at the end here. And it's going to hold, all the way through the back side of this. So this is going to bounce down to here. It's going to come back up to here, back up to here, back down to here. So it's going to do something like this. And then it's going to be solid all the way through this part of the picture. Arrows on both ends, goes on forever. So domain, still going on forever. What's changed is our, in this case, our range, because now it's everything from 0 up to 2. So our range did change from 0 to 2. We still have an amplitude here of 1 because our new midline in this particular problem, and this will be a way we're going to graph these things later, so something to think about. Our new midline is actually now right here. That's the new midline that we would be talking about. And this one would be y is equal to 1 versus y is equal to 0. So that's our new midline. So if you look at the initial point we plotted, it's actually right where it said it was supposed to be. It's right there on that particular thing. So our period here, still 2 pi. Still took us that long to get through it. Now the last one. The last one is saying y is equal to 3 sine x. So we're going to go down here. Still the same values. And now we're going to plug them in. So when I put in 0, I'm going to get 0 still. So it tells me 0, 0, which is right where the old one started. So on that midline. This one, pi over 2. When I put pi over 2, I get 1. 3 times 1 is 3. Well, that tells me now at pi over 2, I'm up here to 3. When I put in pi, sine at pi is 0. 0 times 3 is 0. I'm back down to 0. So I'm back down to here. Sine at 3 pi over that, it's negative 1. Negative 1 times 3 is negative 3. So now I'm going to be well down here. 1, 2, 3, and over to here. And sine at 2 pi is back to 0. So we're back here again. So what happened in this one? It got stretched by a factor of 3. So my a value stretched out. This is going to do something like this. And over on the other side, it's going to do something like this. Now, there's y is equal to 3 sine x. Period. Still 2 pi. That hasn't changed yet. We will change, but not right yet. Our amplitude in this one. Well, the amplitude now was 3. Everything got stretched by a factor of 3. And our range is everything from negative 3 to 3. That would be our sine graph for this one. Now, vertical shift, it said that you had y equals sine x plus 1. So the vertical shift here was plus 1. Just means it went up 1. Hopefully everybody sees how that's working. So now let's just kind of concentrate on one graph at a time. It's kind of tough when you're doing more than one. So let's just concentrate on that. Phase shift. So we talked about a vertical shift. We talked about an amplitude where it's stretching it out vertically. Now we're going to talk about a phase shift. But the phase shift is really nothing more than left to right movement. It's your h value. The phase shift tells us how far the graph has shifted horizontally when compared to the base graph. To find the phase shift, set the input of cosine or sine equal to 0 and solve. So here's what your graph would look like, or your equation. Y is equal to A. I'll say cosine for this one. Cosine of x minus h. Sorry, before I put that, I should say B, because we will have B at some time. And then plus k. So we still have a h, still have a k. And right now our phase shift, this is our phase shift. We're talking about h. Keep in mind when we go to do some of these, you're going to have to divide out a b. That's going to change your h a little. So you got to divide b out if you have one other than 1. So let's take a look at this one. Example number 3. We're going to graph y equals 2 cosine of x plus pi. Then we're going to list our period, amplitude, domain, range, and phase shift. So if I look at this one, it said, take this thing, set the input. Well, the input is this right here. That's what you're putting in. So x plus pi is equal to 0. And so x is going to equal negative pi. What it's telling you, this is your phase shift. And it's telling you that you are going to shift this graph negative pi. Now, just like we had a midline, we have the same situation happening here. Okay, we have a midline. Our midline isn't changing because there's no k value here, that's only an h. So our midline is going to stay right where it was. What's changing is our vertical axis. And our vertical axis is changing by negative pi, which means this is our new vertical axis. And now everything is going to get graphed according to this new crosshair, if you want to say it like that. Everything will start there. Hopefully that makes sense. So when you go to do this, your points should be the same relationship. They should just be a little bit different in terms of how we're going to do this because everything got shifted. But the pattern for this should stay the same. Period. Still should take us 2 pi to get through this. Amplitude, that's our A value. It's 2. Domain, that doesn't change. It's always going to be all real numbers. Range, well, if my midline is at y equals 0, then my amplitude tells me it's got to go up and down 2, which means it's going to start at negative 2 and it's going to go to 2. And my phase shift, well, my phase shift was negative pi. And now I'm going to graph the same way I graphed before. Okay, I'm not changing anything in terms of the graphing part of this. What I am changing is where I'm going to start. Until we get a little further along where we kind of find some shortcuts, and I'll start showing those later. This is kind of how we want to look at this, because this is brand new to us. Normally, I would start this at 0, but the phase shift said I got to shift it by negative pi. So I'm going to just shift it by negative pi. If I shift it by negative pi, when I put negative pi in here, that should be 0. And cosine at 0 is 1. And 1 times 2 gives me 2. Now, I'm going to take each progressive spot that we would have picked normally, meaning I'm going to skip 2 lines, but in this case, I'm going to use negative pi over 2. If I use negative pi over 2 and I add pi, meaning I'm going to add pi over 2 pi over 2, well, 2 pi over 2 minus pi over 2 is 1 pi over 2. What's cosine at pi over 2? Well, cosine at pi over 2 is 0. So I started at 2. I'm going to put a 2 here. I started at 2, and now I'm down to 0. And the next value I should put in, well, I should put in 0 now. When I put in 0, it's going to say cosine at pi. Cosine at pi is negative 1 times 2 is negative 2. So now I'm going to go 0, and I'm going to go down to negative 2. Then I'm going to put in the next one, pi over 2. When I put in pi over 2, now it's saying pi over 2 plus 2 pi over 2, which is 3 pi over 2. What's cosine at 3 pi over 2? It is 0. I'm back up to here. And then the last one, I'm going to be putting in pi. When I put in pi, I get 2 pi. Cosine of 2 pi is 1 times 2 is 2. That is one complete revolution for this particular graph. Now, hopefully you see that the pattern is the same. The amplitude changed and it stretched it out a little, but the pattern itself is still the same. So as long as I know where this new vertical line is and where I'm going to start, then all I need is just a little bit more to tell me where I need to go for the next ones. And as I said, we're going to add on to this. So for now, this is what you're looking at. For here, we're going to go down through this point, bounce off this point, back up through here. That is the main one that we're talking about. But like all the other ones, we are going to extend this. So this is going to go like this. And over here, we're going to go like this. And that is our graph completed. Hopefully you guys see how that works and see what we're doing here. It's still going to be the same process. In this next one, they want us to graph 2 sine of x plus pi over 2. Doesn't ask us to list all that stuff, so we're just going to figure out where we are here. This pi over 2 equals 0, so x has got to be negative pi over 2. So they want us to shift this next one by negative pi over 2. So I'm going to go over here to negative pi over 2. Here's my new graph. This one's sine. So I know sine always starts in the same place. Sine always starts at the 0, 0 of your new axis. And since this is our midline, because we haven't shifted off, or we're not shifting off of this right now, it should be that it starts right there. That's where it should start. But let's take a look and make sure that's the case. It said to start at negative pi over 2. Well, if I put negative pi over 2 in here, that's going to make that 0, and sine at 0 is 0, so this is all 0. So at negative pi over 2, I should be at 0. That's exactly where it said I should be. Now, there's a vertical stretch of 2. Normally, I would go over to the next line, which in this case is going to be 0, because sine at pi over 2, when you put in 0, is 1, and 1 times 2 is 2. That means I should be right up here, and that's exactly where it is. The next one, I should be coming back down to the midline. So the next value I put in should put me at 0 again. It's saying pi over 2. So if I put in pi over 2, I get 2 pi over 2. 2 pi over 2 is pi. Sine at pi is 0. What do you know? We're right back where we started. The next one, pi. This is the same idea. We should be putting this, if we think about our pattern, this should end up right here. Well, let's find out. If I put in pi, I get 2 pi over 2 plus pi over 2. That's 3 pi over 2. Sine at 3 pi over 2 is negative 1, and that's going to be negative 2, which is exactly where we said. And where's the last one? Where should it be? Well, it should go back to the 0 if we're following the pattern. So 3 pi over 2 would be the next one I would put in. 3 pi over 2 plus 1 pi over 2 is 4 pi over 2. That's 2 pi. What is sine at 2 pi? 0. So this one is doing something like this. And it should just finish out. So we would be doing something like this on this side. Over here, we'd have to go down, back up, back up. So this one's going to be doing something like this. And there's our picture, sine. Like I said, we're going to talk about using that pattern, and we're going to talk about this idea of a gap amount. How far do we need to go to pick the next one? And then just use the pattern, because the pattern stays the same. I don't want to keep creating tables, but for right now, we'll do it in this particular sense. The next one, state the phase shift and vertical shift for each of these. So phase shift. Does it move right or left? Well, this one's going to move by negative pi over 4. Remember, take x plus pi over 4, set it equal to 0, and solve for x. Vertical shift, is this moving up or down? Well, it's moving up 3. Phase shift for this next one. Set this equal to 0 and solve. That's going to be negative pi over 7. And vertical shift is going to be down 19 or minus 19. And then the last one, phase shift. This one is saying it's going to be shifting by 3 pi over, or just 3 pi, excuse me. And it's saying it's going to shift in which direction here? Well, it's going to be positive. So this one's going to say that we have a phase shift of 3 pi and then a vertical shift of plus 11. That's really all it is to vertical and phase shift. I hope these make sense. I know this one's running a little bit long, right at 30 minutes, so hopefully we're good. Remember, ask your questions. Always important. Bye, guys.